Why do constipated women appear to be at higher risk for breast cancer? Results suggest a slight increased risk of breast cancer for both decreased frequency of bowel movements and firm stool consistency. Whereas women who have 3 or more bowel movements a day, I call them super poopers, sounds like an ABBA song, appear to cut their risk of breast cancer in half. This could be because constipation means a greater contact time between our waist and our intestinal wall, which may increase the formation and absorption of fecal mutagens, substances that cause DNA mutations in cancer, into the circulation, and that could end up in the breast tissue. This concept dates back more than a century, where severe constipation, so-called chronic intestinal stasis, was sometimes dealt with surgically. Figuring that the colon was an inessential part of the human anatomy, why not cure constipation by just cutting it out? What they noted, though, was that potentially precancerous changes in the breasts of constipated women seemed to disappear after the surgery. It would take another 70 years, though, before researchers followed up on the clues by those distinguished surgeons who claimed that breast pathology cleared when constipation was corrected. So they investigated the relation between potentially precancerous changes in the breast and the frequency of bowel movements in nearly 1,500 women. They found 4 times the risk in women reporting 2 or fewer bowel movements a week, compared to more than once daily, who had the lowest risk. We know that even the non-lactating breast actively takes up chemical substances from the blood, so maybe substances originating in the colon might enter the bloodstream and reach the breast. We know there are mutagens in feces, so it's not unreasonable to suggest that potentially toxic substances derived from the colon have damaging or even carcinogenic effects upon the lining of the breast, and those toxic substances may be bile acids. First shown to promote tumors in mice in 1940, subsequent experiments on rat led to the mistaken belief that bile acids just promoted existing cancers, but couldn't actually initiate tumors themselves. However, there's a fundamental difference between rodent models and human cancer. Rats only live a few years, and so the opportunity for cancer-causing mutations may be at least 30 times greater in humans. Now we have at least 15 studies showing that bile acids can damage DNA, strongly suggesting that they can initiate new cancers as well. Bile acids are formed as a way of getting rid of excess cholesterol. Our liver dumps bile acids into the intestine for disposal, assuming our intestines will be packed with fiber to trap it and flush it out of the body. But if we haven't been eating whole plant foods all day, bile acids can be reabsorbed back into the body and build up in the breast. Carcinogenic bile acids are found concentrated in the fluid of breast cysts at up to 100 times the level found in the bloodstream. They just kind of suck it up and concentrate it. By radioactively tagging bile acids, they were able to show that intestinal bile acids rapidly gain access to the breast, where they can exert an estrogen-like cancer-promoting effect on breast tumor cells. This would explain why we see 50% higher bile acid levels in the bloodstream of newly diagnosed breast cancer victims. These findings support the concept of a relationship between intestinally derived bile acids and the risk of breast cancer. So how can we facilitate the removal of bile acids from our body? Well, we can speed up the so-called oroanal transit time, the speed at which food goes from mouth to toilet, because slowed colonic transit can increase bile acid absorption. Now, we can do this by eating lots of fiber. A diet packed with plants greatly increases bile acid excretion. Fiber can bind up and remove toxic elements like lead and mercury, as well as cholesterol and bile acids. But plants can bind bile acids even independent of fiber. Vegan diets, for example, bind significantly more bile acids than lacto-ovo or non-vegetarian diets, even at the same fiber intake, which could explain why it appears that individuals eating vegetarian might excrete less mutagenic feces in the first place.